Hello, Mr. Barton here, and welcome to another GCSE Maths question of the week, where every week I try my very best to find you a wonderful question that's going to help you prepare as best as possible for the demands of your GCSE Maths exam. Now, the questions I pick are either brand new specification content, so stuff brand new to the GCSE, or questions that are causing a bit of a nightmare for students on my Diagnostic Questions website. And let me tell you, this question is causing no end of trouble for students. They're having an absolute nightmare with this one. So I thought it would be a perfect one to cover. And also, selfishly, I'm more than happy to do this one because it's about probability. And I flipping love probability. So let's take a look at it. It's been written by OCR and it goes something like this. You spin the above fair spinners twice. What is the probability of getting a total of 2 when you add the scores together? So I'm going to take the first spinner, spin it, take the second spinner, spin it, add the scores together. What's the probability I end up with a total of 2? Now, this essentially combines two maths topics in one. You can do it by doing a tree diagram, but the problem is it's going to be flipping massive and it's going to take you forever to do. So we're going to look at a more logical, quicker, efficient way of doing it, okay? So when we get probabilities, more often than not, they're written as fractions. So we have a number on the top and a number on the bottom. Now, the number on the bottom is the total number of outcomes. So how many different things can happen? The number on the top is the things we want. So the number of outcomes we want divided by how many total outcomes can happen altogether. Now, if we can figure those things out, we've got our answer. All right. So I'm going to deal with the bottom number first. How many different things can happen? Well, when I spin a 1, I could get a 1, I could get a 2, I could get a 3, or I could get a 4. Okay. And if I spin a 2, I could get a 1, I could get a 2, I could get a 3, I could get a 4, or I could get a 5. So how many different things could happen there? You might be tempted to say 9 because there are 4 things on one and 5 on the other, but that's not quite true because if you get a 1 on the first spinner, you could get a 1 on the second spinner. So that's one possibility. If you get a 1 on the first spinner, you could get a 2 on the second spinner. There's another possibility. You could get a 1 on the first and a 3 on the second, a 1 on the first and a 4 on the second, a 1 on the first and a 5 on the second. So straight away, we've got 5 different possibilities there. But that's just starting with a 1. Imagine instead that you got a 2 on the first spinner, where you could get a 1 on the second spinner, a 2 on the second spinner, and so on. So for each one of these numbers, there's going to be 5 different things that can happen. So for everything you get on the first spinner, you could get 5 different things on the second spinner. So how many different things are we going to have? Well, with that 3, we're going to have 5 as well. And with, let's treat myself to this colour. Never used this one before. Nice. We're going to get 5 as well. How many is that in total? Well, that's 20 different possible outcomes. So there are 20 things that could happen. So now my only question is, how many of those give me a total of 2? Well, we can see this here, right? The only way I reckon you're going to get a total of 2 is if you get a 1 on the first spinner and a 1 on the second spinner. A 1 and a 1, I reckon, is the only way you're getting a 2. How else are you going to get it? Because if you get a 2 on the first spinner, anything you get on the second spinner is going to take you too high. So the only way of doing it is getting a 1 and a 1. So how many different ways are there of getting a 2? There's only one. 1 out of 20. And if I have a quick glance at my answers, fortunately 1 over 20 is one of the answers. But don't even think about stopping there because hardly anybody's getting 1 out of 20. They're all coming out with all these other answers. So if you want to understand this in depth, it's very important we have a look at some of the other wrong answers. Okay. B, where the flipping heck is 2 over 9 coming from? Well, 2 over 9, I reckon, comes from students saying there are 9 possible things that can happen. They're just doing 1, 2, 3, 4, and then 1, 2, 3, 4, 5. So there's your 9. And 2, either because it's a total of 2, so the answer must be 2, or they think we can get a 1 and a 1 and a 1 and a 1. But of course, they're the same thing, so there's only one possible outcome. Okay. What about C? 4 out of 9. Now, this is a weird one, I must admit. The 9 we've seen, so that's getting 1, 2, 3, 4, 1, 2, 3, 4, 5. Where the flipping X4 come from? Well, I reckon that's come from saying you could get a 1 and a 1. You could get a 1 and a 1. or you could get a 2 here, or you could get a 2 there. So counting up those 4, but if you set it out like this in this diagrammatical form, you can't possibly end up with that answer because you'll see there's only one way of ending up with a total of 2. Okay, and finally D, 2 over 20. Now I have a bit of sympathy for this 2 over 20 because the 20 bit's right. I like the 20 bit. Where's the 2 come from? Well, again, it's either come from saying you could get a 1 and a 1 and a 1 and a 1, so inventing another way of this occurring, or by just thinking, well, it's a total of 2, so let's stick a 2 on the top. So hopefully you can see by that that this diagrammatical way is the best way of representing this. I always challenge students to come up with an alternative wrong answer. I was trying to think what mine might be for this. I might go for that, just 1 over 9. 9 is so tempting to get. 4 and a 5. So tempting to come up with 9. And then the 1, from realising that the only way you're going to get it is a 1 and a 1. There's only one outcome, so that bit's right, but that bit's wrong. So I might go for 1/9, I think, for that one. But look, this combination of events, that's what this topic's about, is a real tricky one. But my strong advice would be, before you launch into a tree diagram, just think, can I represent this in a more logical, efficient way? And then if so, do so. If you can't, a tree diagram's fine, but the last thing you want to do is try and do this without a diagram at all, because that's when you start ending up with 9s on the bottom of your answers. And we've seen that 9s on the bottom of your answers, unfortunately, don't get you the right answer. So my strong advice, try the rest of this quiz out. It's a beautiful quiz. It's got some wonderful probability questions. I've tried it about 20 times, so I love it so much. Absolute classic. And if you need some help on probabilities of combined events, hop on my website and you'll find loads of videos and all that kind of stuff on there. And I'll see you for a fresh question of the week next week. Take care. Bye for now.